Okay, let's crack straight on with the chemistry section. Question 4 in your test is about atomic structure, and figure 1 represents an atom of element Z. Z is just being used here to give this thing a name. It isn't a symbol. We're not going to find Z on the periodic table. Let's go straight into the question. Name the parts of the atom labelled A and B. You can see that A is referring to all of this stuff in the centre of an atom. I'm picking out the correct word from the box. A is the nucleus. And then around the nucleus in the shells or the orbits, we're identifying what's represented by an X here, and we recall that this is an electron. Now, fact, when I see group on the periodic table, I think to myself, the outer shell of electrons, I'm going to count them, and whatever I count in the outermost shell is the group. 1, 2, 3, this element is in group 3. Okay, part C, we are being asked to find the atomic number and the mass number. So recall, the atomic number is the protons, and the mass number is the protons added to the number of neutrons, and we should recall that that is the subatomic particles that make up the nucleus. Annoyingly, I'm going to have to flick back to my diagram here and have a look, and if you count on your sheet, you can see they are little pluses. 1, 2, 3, 4, 5. There are 5 protons here in the nucleus, and the other particle is the neutron. 1, 2, 3, 4, 5, 6 neutrons. 5 protons and 6 neutrons. So, going back to our question, the atomic number, which I'm remembering is the proton number, that is 5. And the mass number is the total number of particles in the nucleus. 6 neutrons and 5 protons makes a mass number of 11. Bromine has 2 different types of atom. The atoms have a different number of neutrons, but the same number of protons. So this fact, the same number of protons, tells me they are the same element, and the different number of neutrons tell me that they will have a different mass. Atoms of the same element with a different mass are called isotopes. On to question 5. This question is asking us about separation techniques. Okay, you have learnt a number of separation techniques. They're about separating mixtures. Mixtures can be easily separated, and depending on the mixture, we can use a different technique. Chromatography, the word chroma at the start refers to colour. Chromatography would be used to separate the blue food colour from a mixture of other colours. Crystallization. Crystals form when you evaporate a solvent and leave behind the solute. So, for example, if you've evaporated a solution of salt, then you'll be left with salt crystals at the end. So, crystallization is a purification and a separation technique. The best answer, the only answer, to get copper sulfate from copper sulfate solution. Okay, I've got some information here. It says sand does not dissolve in water. A student separates a mixture of sand and water by filtration. Draw a diagram of the apparatus the student could use. So I need to have a funnel. My funnel's going to need a piece of filter paper inside it. And I need something to collect the liquid part that's going to drip through the funnel. I've used a conical flask. Notice I'm being asked to label where the sand is collected and where the water is collected. First of all, I'm just going to label my diagram. A funnel, a filter paper, a conical flask, but you could use a beaker or a test tube, or a round bottom flask, anything is suitable. When you pour your mixture of sand and water in here, the sand will collect on the filter paper. So I need to label where the sand is going to end up, and the water will drip through, and I'll be able to collect the water in the conical flask. Okay, part C is about distillation. The student distills a sample of salt solution to produce pure water. I've got a diagram of standard apparatus to do distillation with, and the question is, what temperature would you expect the thermometer to show? So think what's happening here. I'm heating up my salt solution. It's going to be boiling so that the water vapor is rising up here and entering the condenser. Distillation works because the water is going to boil and the salt is going to be left behind. Water boils at 100 degrees Celsius. Okay, we've got 4 marks here to score on describing. So describe means what's going on, not why, what is going on. Describe the process of distillation produces pure water from the salt solution. So I'm going to end up with my final sentence being, therefore pure water collects in the beaker. Okay, let's try and split it up. 4 points, 4 bullet marks. Down the side here, I'm going to say, have we said that we heat the solution, and because we heat the solution, the water evaporates or boils. The water vapor is going to enter the condenser and cool down. The job of the condenser, there's a clue in its name. The vapor is going to cool down and turn back into a liquid. It's going to condense in the condenser. And I've got my final sentence. The pure water that I've produced, distilled water, is going to collect in the beaker. So a good tip in exams, 4 marks, 4 sentences, 4 bullet points. Question 3 is about elements and the periodic table. We should know some facts about the early periodic table, and Newlands and Mendeleev were both scientists who worked on early periodic tables. In both cases, they arranged their elements in order of atomic weight. The reason they did that was because neither of these scientists knew anything about the structure of atoms, but they did know about the weight of different elements. Once we started to understand that atoms were made out of protons and neutrons and electrons, the particle that the modern periodic table is arranged in order of, the proton, matched up with Mendeleev's early periodic table exactly, and we've got the periodic table that you use today. Okay. Question B, part 1. I've got 9 elements shown. When you get questions like this, the answers are picked from the elements that have been shown in the diagram of the periodic table. And the question is asking us to identify which one of the elements shown has the lowest boiling point. So when you get questions like this, always think things with low boiling points are gases. I know that all of group 1 metals are solids, and copper is a solid. So I'm over here in group 7, the halogens, and a fact that I need to remember, that the lowest boiling point element in group 7 is at the top, and it's called fluorine. You can remember this trend because fluorine and chlorine are both gases, so they've got low boiling points. Bromine is a liquid at room temperature, its boiling point is a bit higher, and iodine is a solid at room temperature. So you can see the trend by looking at their states of matter. Now the final part here is worth 4 marks again. Okay, we're being asked to explain. We're talking about the reactivity of the elements and why group 1 gets more reactive as you go down the group compared to group 7, which does the opposite and gets more reactive up the group, or less reactive down the group. Okay, and this is all about understanding what these elements are doing when they want to make bonds and do chemistry. So group 1 metals want to lose one electron from their outer shell, and they are going to make positive ions. Whereas group 7, when they do chemistry and react, they want to gain one electron, and they are going to make negative ions. So in our explanation, we've got to explain why that happens easier in a certain direction according to the position of these elements in their group. So remember, as you go down the groups, the atoms are getting more and more energy levels of shells, and they're getting larger and larger. So the key point to mention here is the distance to the nucleus. And the reason that is important is because we're only talking about the outermost energy level of electrons. The outermost energy level electrons is attracted to the nucleus because electrons are negative and the nucleus is positive. So in group 1, rubidium, in our example here, or the bottom of group 1, the bigger the atom, the bigger the distance to the nucleus, it's easier to lose an electron. So the bottom of group 1 is the most reactive, whereas in group 7, the smaller the atoms are, there's a bigger pull from the nucleus, which means it's easier to gain, and that's what they're trying to do. So if you want to be a very reactive metal and make positive ions, it's best to be big. And if you want to be a very reactive non-metal and make negative ions, it's best to be small. So it's all about how easy it is to lose or gain electrons and form ions. Okay? The bottom of group 1 make positive ions the easiest because their outermost electron is furthest from the nucleus, whereas the bottom of group 7, the iodine, is the least reactive because the large atom means it's difficult for iodine to attract an electron and fill up its outermost shell and make negative ions. Finally, make sure when you finish off this that you're only talking about the outermost energy level or the outermost shell of electrons. That's the only part of these atoms which are involved in making bonds, and so metals are trying to get rid of the electron or electrons in their outer shell, and non-metals are always trying to gain electrons to fill up their outermost shell. Remember that all ions have the same electron arrangement as group 0, because by making bonds, these atoms are becoming more stable by having a stable arrangement of electrons, and all of their shells are complete.